Okay, so let's do part 2 of angles of polygon. So welcome all my grade 9 elite students and my grade 10 advanced students. So we are continuing our lesson 2.1 angles of polygons. And if you remember in the last video, which was on interior angles, we talked about the formula. So there are two types of angles that are possible. One is interior angle of the polygon and one is exterior angle of the polygon. So as the name suggests, interior means inside, so the angles are going to be inside the polygon. And if exterior, then they are going to be outside the polygon. So for inside, the formula for sum of all interior angles of a polygon was n minus 2 times 180 degrees, as you saw, where n is the number of vertices or the number of sides of the polygon. And in today's session you will see that sum of all exterior angles of a polygon is equal to 360-degree always, whatever is the number of side, whatever is the number of angles. So don't get confused between the two of them. One is interior, one is exterior. Accordingly, there are different formulas: n minus 2 multiplied with 180 for sum of interior and 360 degrees always for exterior. So let's get down to our video today. Let's get started and look at the learning objectives. So in today's session, our goals would be the following. If you have seen the last video, then you have seen that we have completed the first learning objective. That is, we have proved and we have used the polygon interior angle sum theorem, which was n minus 2 multiplied with 180, just now what I said. And in today's session, our learning objective would be to prove and use the polygon exterior angle sum theorem, which is going to be the sum as 360. So let's get started. And before we go to exterior angles, a quick recap, a revision, a recall from the last video on interior angles. So as you see here, you have to find the measure of each interior angle. And if you see these polygons, QRST, it's a quadrilateral, four-sided figure. Similarly, JMLK, this is also four-side. So our value of N is 4 here for both of them. Okay, now if you look at the angles, then this angle, this angle, this angle, this angle, QRST, we are looking at interior. They are inside the triangle. That's why we are going to apply the formula n minus 2 times 180 degrees, which is valid for interior or inside angles of a polygon. So they are inside. Similarly, this angle J, K, L, M, all are inside. So when you are going to sum the interior angles, that is, what are the interior angles here? Q, R, S, T. The sum is going to be n minus 2 times 180 degree. Now n is 4 already, so this is 4 minus 2, which is 2 times 180 degree or 360 degree. Okay, so let's put in the values. Angle Q is 2x plus 5, angle R is x, angle S is 2x plus 7, and angle T is also x. Now to solve this, you have seen in the last video also, we take the like terms together. So x, all these terms are common. So 2 plus 2, 4, 5, 6. 6x plus just the numbers. So 5 plus 7, that's 12, is equal to 360 degree. Now I'm not going to solve the whole of the question. You can similarly solve this equation. It's in one variable x, and you will get your value of x, and therefore you can get all the angles. In similar way, here your J plus K plus L plus M is going to be 360 degrees. The sum is going to be 360 degree because here also the number of sides n is 4. So n minus 2 is going to be 2, and that you multiply with 180. So let's put in the values. 3x minus 6 plus x plus 10 plus x plus 2x minus 8. This whole sum is going to be 360 degree. So you can very well solve this, combine the like terms together and the numbers together, and solve this equation. So that's how you get the measure of each angle of the interior angle of the polygon. So that was a quick recap. So let's apply the interior angle theorem for the pentagons that you see here. So here A, B, C, D, E, there are 5 vertices. Similarly, U, V, W, X, U, V, W, Y, Z, there are 5 vertices. So N is 5. Now if N is 5, the sum of the interior angles would be N minus 2 times 180 degree, which is 3 times 180 degree. So this will come out to be, on simplification, 540 degree. So the sum of all angles for both these questions would be 540. So let's apply the theorem. Angle A plus B plus C plus D plus E is coming out to be 540. I hope you understood how we got this 540, and let's plug in the values. So this symbol tells you this angle is 90 degree. Similarly, this symbol tells you this angle is 90 degree. So 90 plus 90, then angle C, 2x minus 20 degrees, then x degrees, then 2x plus 10 degrees. So this is going to be equal to 540. Now we'll combine the like terms. So 90 plus 90 minus 20 and 10. So 90 plus 90, 180, plus 10, 190, minus 20, 170, plus 2x plus x plus this. So this is 5x equal to 540. Now 5x is equal to 540 minus 170. So you are going to subtract them two and then divide by 5. So this will come out to be, let's simplify, 540 minus 170, that is 370, and that is 5x. So we divide by 5 on both sides. This cancels here, and when you divide by 5, this comes out to be 74 degrees. So the value of x is 74 degrees, and therefore you can simply also find angle C, which is 2x minus 20. So it will be 2 times 74 minus 20, and you can simply also find angle D is already 74, this is 90. So similarly you can find angle E. Angle E would be 2x plus 10, so that is 2 times 74 plus 10. So in this way you can find all the angles of the pentagon. Similarly you can solve the next question, which is question number 4, in a similar manner, and this is going to be the same method as the sum of the sides is same. So these are the methods of solving. So just apply here very quickly. I will write one step for you. Angle U plus V plus W plus Z plus Y, all of this is 540. So you can just plug in the values here. So U is x minus 8 plus V is 3x minus 11 plus W is x plus 8, then x plus 2x plus 7. So all of this is equal to 540. Simplify it in a similar way, you will get your x and you will get all the angles of the pentagon. Another revision question which I've taken from your book is of this type. It is based on, again, interior angle, if you see. So the measure of the interior angle. Now this time it's a regular polygon. So if it is a regular polygon, all sides are equal. So let n be one of the sides of the regular polygon, then find the number of sides in the polygon. So the measure of the interior angle, one interior angle is given. So for one interior angle, the measure is 144. We are doing question 9 here. Similarly, you will do yourself 10 and 11. So one interior angle is n. So if there are total of n interior angles, n because the sum of all interior angles. Now the sum of all interior angles, you know the formula is n minus 2 times 180. N is what we need to find here. We need to find the value of n. That's what we don't know. Now we know that n interior angles are there. So if all of them are equal, because all sides are equal, so all angles are also equal. So all interior angles, one interior angle has 144 degrees. So n interior angles would have 144 multiplied with n. So that's equal to n minus 2 times 180. Let's solve this. We are going to use distributive property. So this is coming out to be 180 times n minus 360 degree. Now we need to solve for n. So I'm going to take this 180 on the other side. So 144 minus 180 is going to give you minus 36n equal to minus 360 degree. So negative negative becomes positive, divide by 36 both sides. So n is equal to 10. That means there are how many sides of the regular polygon? The number of sides is 10. So it's a decagon. Okay, so I hope you remember the number of sides of the polygon were taken as n, or the measure of each equal angle will also be this one. So that's how you solve the question. Now let's come to a topic for today, which is exterior angles of the polygon. And as I told you, exterior means outside. So these angles, look here now, if this is a polygon given to you, then angle 1, angle 2, angle 3, angle 4, angle 5, angle 6. Can you see they are outside? This is the measure, this is the measure, this is the measure, this is the measure of angle 3, angle 2, angle 1. So all of these are lying outside the polygon, and when they are outside we apply the polygon exterior angle sum theorem. What does it say? It says the sum of the exterior angles measures of a convex polygon, one angle at each vertex is 360. So whatever is the number of sides, whatever is the number of vertices doesn't really matter here. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6. When you add them all exterior angles, the sum is always 360 degrees. So this you have to remember, you have to differentiate. Don't get confused with interior angles. If interior angle, then n minus 2 times 180, but if it's exterior angle, always 360. So let's solve a question. These are the exterior angles. As you can see, one angle is 2x, one angle is 88, one angle is x plus 10, one angle is x plus 2, one angle is 52. So let's add all the angles. So sum of all exterior angles. In this question, you know you have to apply exterior angle theorem. How you will know? Because these angles are outside the polygon, they are not inside. So because they are outside, their sum is 360. So let's put the value 2x plus 88 plus x plus 10 plus x plus 2 plus 52. All of them is 360. Now let's combine the like terms. So the like terms here for the angle is 88, 10 and 52. So 88 plus 10 plus 52 will be taken together, and 2x, x will be taken together. So 2x plus x we know is 4x equal to 360. So let's just add 88 plus 10 plus 52 is 150 degrees. So 150 degree plus 4x is 360 degree. So 4x is equal to, take this 150 on the other side. When it moves here, it changes the sign, it gets subtracted. So this is going to be 0, 1, 2. 210 is 4x. Let's divide by 4 on both sides so that you get the value of x. So your final value of x, which is 210 divided by 4, would be 52.5. Okay, so the closest value that you see here is 52. So B is your answer. A regular dodecagon has 12 congruent sides. So if you remember from a previous video which was on interior angles, do means 2, decagons mean 12. So total it has 12 sides. And it's a regular dodecagon. So all 12 sides are same, or they are equal measure. That's why 12 congruent sides and 12 congruent interior angles accordingly. Now, the exterior angles will also become congruent because angles supplementary to congruent angles are congruent. If you look at this parallelogram, this is interior angle x, then this is exterior angle 180 minus x, right? So they are supplementary. The sum of interior plus exterior is 180 degree. That's why the exterior angles are also going to be congruent, and let n be the measure of each exterior angle, and let's write an equation and solve it. So since n is the measure of one exterior angles, there are going to be 12 exterior angles, so the sum of total of them will be 12n, and that is equal to 360 by the Polygon exterior angle theorem. So if you add all of those exterior angle, n plus n plus n, how many times? 12 times. Why 12 times? Because there are 12 congruent sides. So it will come out to be 12n. That's how you get it. Now you divide by 12 both sides. N is 30 degrees. So the measure of each exterior angle of the regular dodecagon is 30 degrees. That's how you solve the question. Now let's solve a question together. We have a regular octagon. Octagon has 8 sides. So there are going to be 8 congruent exterior angles. So you have to add n plus n plus n. You have to take its sum. How many times? 8 times. So this is same as 8n, and by the exterior angle theorem the sum is 360. So this is going to be 360 degree. So very simply you have to just solve for the measure of one angle here. So 360 divided by 8, you divide both sides by 8, this cancels, and you get n as 45 degrees. So what is the measure of each exterior angle? So the measure of each exterior angle of which polygon? Regular octagon. Of regular octagon. So the name octagon suggests it has 8 sides is 45 degrees. That's how you solve for exterior angle. Now I have taken some questions from your math book on exterior angles, and I know you can simply just look at them and tell them. So 1, 2, 3, 4, 5, 6 sides here, 1, 2, 3, 4, 4 sides here, doesn't make a difference. The sum of exterior angle of any polygon, number of sides, number of angle doesn't matter, is always 360 degree. So what you have to do exactly? 2x plus x plus 10 plus x plus 18 plus 3x plus x minus 1 plus x. Just take them all, add them all, and make them equal to 360 degree. That's all you have to do. So this is equal to 360 degree. Let's solve for x. We'll take the like terms together. So 2x plus x plus x plus 3x plus x plus x. So 2 plus 1, 3, 4, 5, 6, 7, 8, 9. 9x plus 10 plus 18 minus 1. So 10 plus 18 is 28, minus 1 is 27. This is going to be equal to 360. So let's just do the simplification, do the calculation. So I take 27 on the other side, it becomes 360 degree minus 27, which is 333, and this is equal to 9x. So when 9x is equal to triple 3x, triple 3 degrees, you divide by 9 both sides, this and this cancels, and this gives you the answer as 37 degrees. So x is 37 degree. You have to just find the value of x. Now here also you will do the same thing. The only difference is there are only 1, 2, 3 and 4 angles. So when you take these 4 angles, the sum is going to be 360 degree again. So x plus 10 plus 31 plus 2x minus 42 plus x minus 11 degrees. Put that equal to 360 degree and solve for x in a similar way that we have done here. Just simplify and let me know in the comment section what is your value of x for question 16. Last question for today would be question number 19. You are going to try question 20, 21, 22, 23, 24 on your own in a similar way. So this is the last question on measure of an exterior angle of regular polygon. Now it's a regular polygon, so each exterior angle would be measured n and each would be equal. Now a pentagon has 5 sides. That means the sum of all the exterior angles, how many angles? 5 of them. If I add them, the sum is 360. We are using the sum of all exterior angle theorem for a regular polygon. So this is going to be 5n equal to 360 degree. So you are going to divide 360 degree by 5, and that's how you get the value of measure of each exterior angle as 72 degrees for the first question. Here, what is the value of the polygon? The polygon is having 15 sides, so you will do n plus n how many times? 15 times, and this sum will be equal to 360 degrees. So 360 degree is equal to 15n. Divide by 15. Very simple questions we have in today's session. So this is going to be giving you 360 degree divided by 15 as 24. So the measure of the exterior angle of 15 gone. 15 gone means a polygon having 15 sides. So I will just write here in case anyone doesn't know, polygon having n sides is 15 sides. So exterior angle of the 15 gone is 24. The exterior angle of the pentagon means 5 sides is 72 degrees. So that brings us to the end of today's session. I hope you found the session useful and you have understood the difference between interior and exterior angles of a polygon. Until then, this is Ms. Ruchika signing off from today's session. If you found the video useful, give it a thumbs up, share it with your friends. And that's all for the session today. See you in my next video. Bye, students.